So here's an example of what you could do for your matrices project. As you can see here, the first slide, I have already created my story problem, and it needs to be like a real world problem. So you can make it up however you like, but make it, I would say, make it interesting, or you can use the two defaults that I've provided you on your project handout. But your story should lead you to have two matrices, so keep that in mind. And it should also have other quantities. As you can see here, there are price numbers here, which you'll see how I use those to create an extra set of matrices later when I'm doing my multiplication matrices. So I'll show you that how I do that in like the last slide. So let's get into it. So the first part you should always have in your project is your story problem. You gotta have that written out, or else I'm not gonna know what you're working with. So make sure you write your story problem in your project. So my story says here, Miss Chang has a cousin, Jim, that has a sushi restaurant in Huntsville, Alabama. This is actually a true story, by the way. Well, at least maybe the story's not so true, but I do have a cousin who has a sushi restaurant in Huntsville, Alabama. And this here is a photo of his sushi. So the story says he decides to change the recipe of 3 of his OG, or his original sushi rolls, California roll, tuna roll, and veggie roll, to see how the prices will be affected. So basically he's changing the recipe of his 3 like popular sushi rolls, and he wants to see what the sales is going to turn out to be. And he decides to change the prices of the sushi to $9 for the California roll, $10 for the tuna roll, and $6 for the veggie roll. Jim wants to compare the sales of his morning, afternoon, and evenings. And he asked Miss Chang to do some evaluation on his sushi sales for the next 2 days. My bad. Let me fix that real quick. Scribble that out, 2 days. And here is the data that I've collected, or that he's collected out of those 2 days. So these 2 charts are going to be our matrices. So I'm going to highlight what I need to grab from the matrices. And if you remember this in class, I only grabbed the numbers. So you can see here that our columns are going to be representing either morning, afternoon, or evening. So basically the times. Whereas the rows represents what type of sushi was sold and the quantity that it was sold. So if I wanted to know like how many Californian rolls were sold in the morning of that first day, it was 8 rolls, and so forth. Or I could total this up and get the total amount of sushi that I got in one day. So in the next slide, we're going to start with our first operation, which is addition. So here we go. I'm going to grab those chart numbers and make a matrices. Okay, so here I have the 2 charts. Again, you do not need to rewrite the charts. I just have them here because I need to see what my my matrices was. So like I said, I'm going to grab the values here from this chart and this chart and make 2 matrices. So my first matrix, I have it looks like a 3 by 3, right? They're both 3 by 3s. So this is 8, 6, 10, 6, 7, 13, 5, 6, 8 is my first matrix for my first chart, so day 1. And day 2, I have, 7, 11, and then 12 for Californian, tuna, 4, 8, 15, veggie, 3, 9, 11. So if you remember, how do we add matrices? Well, we always take our corresponding elements and add them together. So I'm going to add, the 8 with the 7. And that would give me 8 plus 7, 15. 6 plus 11 gives me 17. 10 plus 12 gives me 22. So that's the first row that I've just added to each one to get those numbers. Now I'm going to take the 6 and add it with the 4, so on to the next row. And that's 10. 7 plus 8 gives me another 15. 13 plus 15 is 28. And then the next row here looks like I have a 5 plus 3, which gives me 8. 6 plus 9 gives me 15. A lot of 15s here. 8 plus 11 gives me 19. And so now I have my new matrix. Now, if you remember in the project, this part's very important. You also need to tell me what this new matrices represents. So what does it mean to add these numbers with these numbers? Well, the numbers here represents the total amount that was collected for pretty much each category, right? Whether you wanted to know the morning time for California roll, or if you wanted to know the morning time for tuna, or whatever time zone. It could be evening with veggie rolls. So basically it totaled up all the rolls with day 1 and day 2. So this matrices here tells you the total amount of rolls for California and tuna and veggie for each time, so morning, afternoon, and evening, and has them in its categories. So here I've written a little description of what I just said. So I said that the sum of the matrices, so these two matrices, represents the total amount of sushi sold in the 2 days and are organized by the time and the type of sushi. So you can write something like that about your matrix that you've just created from addition, from adding the two matrix. So what I expect from each operation is to figure out, to do the calculation, so in this case, add the two matrices, and then write a little bit about what that new matrix represents. That's all. And this could be just like a sentence, one sentence. Okay, so now we're on to subtraction. We're going to do the same thing. We're going to subtract two matrices, and then we're going to tell a little bit about it. So first off, some of you guys are going to be like, well, which one should we subtract with each other? Should we subtract the first matrices, so day 1 with day 2, or does day 2 subtract from day 1? Well, to be honest, it doesn't really matter which one you subtract. You just have to change your make sure the wording that you describe the way you subtract makes sense to your calculation. So here's what I mean. I'm going to choose to subtract day 2 with day 1. So I'm going to write my matrices here. Here it is. I've set up my problem. So this one was day 2's data. So this is the day 2 matrix subtracting from the day 1 matrix. And so remember, if you subtract, you got to subtract corresponding elements. So that's what I'm going to do here. And like I said, it didn't matter whether I did day 2 minus day 1 or day 1 minus, this one would have been day 1 minus day 2. It didn't matter the order. It just changes your wording a little bit when you explain. So if I were to subtract, here's my new matrices. That's kind of a really bad bracket. Let me fix that. That's going to bother me. Okay, that's better. So I'm going to take my corresponding elements, so the 7 here, subtract it with this 8. Let's see, 7 minus 8 gives me -1. 11 minus 6 gives me 5. 12 minus 10 gives me 2. Now I'm on the second row. 4 minus 6 gives me -2. 8 minus 7 gives me 1. 15 minus 13 gives me 2. 3 minus 5 gives me -2. 9 minus 6 gives me 3. And 11 minus 8 gives me 3. And there we go. Now I have my new matrix, which came from subtracting day 1 from day 2. Sorry, day 2 from day 1. And so let's write a few words for this. So here's what I wrote. The difference of the two matrices, so these two, represents how much more or less sushi was sold in day 2 than in day 1, which should make sense, right? Because if you're subtracting day 2 from day 1, you're seeing how much more day 2 made compared to day 1. So, like, for instance, remember, this column represents morning and this row represents Californian. So it looks like in the morning, day 2 sold 7 rolls, where day 1 sold 8 rolls for Californian in the morning. So that means that actually day 1 sold more. So in this case, day 2 kind of lost one sale. Whereas if you looked in the afternoon, the California roll on day 2, they sold 11 Californian rolls, where in day 1 in the afternoon they only sold 6. So that's like 5 more in day 2 rather than in day 1. So these numbers here are showing the difference in each category. So that's why I said, sushi was sold in day 2 than in day 1, depending on the type of sushi and time it was sold at. So there is a very simple explanation you can explain for the subtraction of the two matrices. So I hope that gives you kind of an idea to work with when you are doing your matrices. Also, I'd just like to add, when it comes to subtraction, in general, when you subtract something from another thing, you're showing how much more that item is compared to another item, if that makes sense, or how much this quantity is compared to that quantity is what subtraction does. Okay, so now we're on to the third operation, which is multiplying by a scalar. So if you remember from our lesson, scalar just represents a number that you multiply with to a matrix. So in this case, here I have day 1's matrix, and I'm going to multiply it by some scalar number. I'm going to choose that number, and also I chose to use day 1's matrix. I could have easily chose day 2. It doesn't matter. It just changes the way I will explain my written part. So let's see what number I'm going to multiply this by. You know what? I'm going to keep it pretty simple. I'm going to multiply it by 2. Just make sure that when you multiply it by a number, don't choose 1. That's way too easy. I want you to multiply it by a number greater than 1. So that'd be 2, 3, all the way up to whatever your heart desires. You could even do decimals. It just makes the explaining part just a little bit tricky, but other than that, whatever number you like to multiply by. So I'm going to choose 2. So I'm going to multiply this entire matrix by 2. Remember, scalars will distribute to every number inside the matrix. So everything will get multiplied by 2. So if I multiply by 2, I got 2 times 8, which is 16. 2 times 6 is 12. 2 times 10 is 20. So that's the first row. Okay, on to the second row. 2 times 6 gives me 12. 2 times 7 gives me 14. 2 times 13 gives me 26. And the third row, 2 times 5 gives me 10. 2 times 6 gives me 12. And 2 times 8 gives me 16. Okay, and I have my new matrix. So this matrix, let's think about how we're going to say that this represents. So here we have an explanation that I wrote for this matrices here. So it says here the matrix that was multiplied by a scalar of 2, where you can see here 2 is being multiplied by day 1's matrix, represents the quantity of sushi sold if day 1 were to double. Which makes sense, right? Because this number here is 2, so we're doubling each number inside when we multiply by 2. And so this matrix has to represent the number of sushi that is sold in day 1, but it's just doubled. So if I want to know, in the evening for tuna rolls, which would be this one here, because the middle one represents the tuna rolls, how many sushis would be sold in the evenings if we were to double it? Well, that means that we would have sold 26. There we go. Okay, so you didn't have to choose 2. You can pick any number. So if you chose 3, then you'd be like tripling the quantity and so forth. So you choose, figure out what number you want to multiply for your scalar, and then write a description based off that quantity. Make sure the wordings match. Okay, so now we're on to multiplying matrices. So if you're on this lot and you haven't learned about multiplying matrices, I highly recommend you need to go watch video Journal 55 and watch that bell work and learn about how we multiply matrices, or else this is not going to make too much sense of why I set it up this way. So what I'm going to do here to multiply two matrices is I have to choose two matrices that make sense with my story to multiply. So for me, I have some prices to work with in my story. I haven't used the price tag for each sushi. If you remember in the story problem, I have listed that Californian rolls cost, what did I price them at? $9. Tuna roll cost $10. And then veggie rolls cost, oh, let me spell that right, $6, I believe. Yep. And so I'm going to use these prices here to multiply my quantity because I want to know how much money I made. So here's what I'm going to do. I'm going to set up a matrix that's going to represent my prices. So my prices, my California roll is $9, my tuna roll is $10, and my veggie roll is $6. So these represent my prices. And then I'm going to multiply that by the matrix of my, let's do day one matrix. So day one's matrix is, let's see, it starts out with 8, 6, 10, 6, 7, 13, 5, 6, 8. So this one is representing day one. I do want to say here, when I multiply this matrix with this matrix, remember the size matters when you multiply matrices. So make sure that when you do it that they check out. So remember, if you want to check that you can multiply these matrices, look at the dimensions. So this first matrix is a 3 by, sorry, not a 3 by, a 1 row and 3 columns, right? 1 row, 3 columns, so it's a 1 by 3. Whereas this one here has 3 rows and 3 columns, so a 3 by 3. So when I look at this here, I know I can multiply these two because the inner dimensions are the same. So whenever the dimensions on the inside are the same number, you can multiply the matrices where we can here. Now, to figure out what this matrix is, when you multiply it, what size the matrix is you look at your outer dimension. So in this case, our outer dimension is 1 and 3. So our new matrix is going to be a 1 by 3. So 1 by 3 means 1 row, 3 columns. It's going to make some room for that. Let me move this. Oh, sorry, that's a highlighter. Let me move this up here. This is going to be a 1 by 3. Okay, so here I go. If you remember how we multiply matrices, we always multiply rows by columns. And here's why. So when I look at this problem, I set it up pretty well because, remember, the columns represent the, this one represents morning, this represents afternoon, and this represents evening. So morning, afternoon, I'm just going to abbreviate, and then evening. So that means when I multiply the corresponding prices with all the mornings, I'm going to get the total amount of money I made in the morning. So my goal is to figure out how much I made in that morning first. So remember, these numbers here represent a certain role. Well, this one here represents the Californian roll. So in the morning, I sold 8 Californian rolls. So Californian rolls cost $9. So I'm going to multiply those two together. This one here is going to represent the tuna roll, and I'm going to multiply the tuna price with that. This one's a veggie roll, so I'm going to multiply by the veggie roll. And then once I multiply all the numbers, I'm going to add them up. So here I go. So I'm going to multiply this row with this column. So that's going to be 9 times 8. 9 times 8 gives me 72. So I'm going to write that here. Let me do that in like pink or something. So I'm doing 9 times 8, which is 72, plus, remember we add after, 10 times 6, which is 60, plus 6 times 5, which is 30. So if I add all these numbers together, let me grab a calculator. I get 162. So it looks like I made $162 in the morning. Now what I'm going to do is figure out how much I made in the afternoon. And I do the exact same thing. The only thing is that I don't multiply the first row by the first column anymore. I have to multiply it by the second column. So here's what I'll do. To show this, I'm going to highlight using the pink maybe? Yeah, let's do pink. I'm going to multiply this row by this column. So in the pink, when I multiply, I have, let's scoot this back just a bit. I have 9 times 6, which is going to give me 54, plus 10 times 7, which is 70, plus 6 times 6, which is 36. And if I add all this together, 54 plus 70 plus 36 is 160. So I made $160 in the afternoon. Okay, last but not least, I have to figure out the evening. So how much total I made in the evening. So that's going to be multiplying, let's pick a different color here. Perhaps I'll pick orange. So I'm multiplying the price again, but now with the third column. So that means I have 9 times 10, which is 90, plus 10 times 13, which is 130, plus 6 times 8, which is 42. Now I'm going to sum all this up. 90 plus 130 plus 42. That's going to be 262. So I made $262 in the evening. And so now I have all the total revenue that I made for each time. So in this case here, I can say a few words about it. Okay, so here's what I wrote. So I basically said that multiplying the price matrix, this matrix here, with the quantity matrix, this matrix here, gives me a new matrix that represents the total revenue I made for the morning, afternoon, and evening. As you can see, this represents the total that I made in the morning, afternoon, and evening. I also said that the total revenue I made in day 1 is 584. If you're wondering how I got this number, all I did is because I knew all 3 revenues, I added the morning, afternoon, and evening together and got how much I made on day 1. That's all. So I added this up and got this number. And that's something I can add to the my explanation here. So I hope that gives you some ideas to do for your project. I really want you guys to have fun with this. Make your story problem interesting, because that's really the how you can be really unique with your project here. And then the rest is making sure the math correlates well with your story problem. And if you need more tips on how you can get some ideas on what matrix to multiply with your matrix that you've created in the beginning, let me know. I can help you out with your story problem. I can help you out with how you want to do your calculations and your explanations. All you got to do is ask. Okay, so that's it for this project example. I hope this helped.